Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to cloud test lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
Thank you.
Krish, I had a question there, Krish. Can you go to that screen, the diagram screen? I forgot the question. No, actually the Eclipse screen, sorry. This priority you mentioned 5, is 5 high priority or the lowest priority?
We'll discuss about priority later.
Okay, Krish.
Which will execute first when we have 2 or more threads. Yeah, Tulsi, that will also discuss in a minute now. We'll span 2 threads and we'll see how to execute those 2 threads. Now, until now we have discussed about thread static methods only. Let's start using thread object methods. So we just used start or run method, and let us go and see the API for some other methods. The next method we can take a look at is set name and get name. Currently the name of the thread was thread-0, and let us say if you have created all the thread names will be thread-0 to thread-10, which is we can't remember for what purpose we have created a thread. Instead of that, if you want to set the name based on your inputs, you can call the thread object dot set name method. Set name method accepts a string value and you can pass the name of the thread. If you have set name, you'll have get name as well. Get name method, which is used to return the name of the thread. You can also change the name of the main thread as well. If you want, you can also change, let us say, thread dot current thread. This is my main thread. Main thread dot, currently I got a thread reference. So once I got a thread reference, I can make use of any of the method calls. Main thread dot set name. This is my main thread. So here you have created a child thread also. You should specify the set name method before calling the start. If you call start and specify the name of the thread, there won't be any use. The run method has already completed, or else it will take some time to get the CPU cycle for main method to set the name of the thread. So let us say this is my child thread 1. Now, if you go and execute this one, print the details of main thread. You can see that the name of the thread has changed to main thread, and you can see that the name of the child thread also changed. If you want, you can just retrieve the name of the thread later points, and you can make use of that for some other purposes. Just for your understanding only, they have provided two methods to set the name of the thread. The thread group was created by the JVM, so you can't change the name of the thread group. Next one is isAlive method. isAlive method, this is also a normal method from your thread class. That means you are supposed to call this method on a thread object only. isAlive method will return true or false. So the return value is a Boolean value. If the thread is running, still in running mode or in waiting mode, in those cases, it will return the value as true. If your thread has completed execution, it will return the value as false. So the isAlive method can be used to identify whether the thread is still running or not. So currently you can see that in my main thread, I'm checking whether my child thread is still alive or not. You can see that I received a status called child thread alive status is true, because our main thread has completed first and our child thread has completed later. So still our child thread is running mode. Let us say go and ask our main thread to sleep for 2 seconds. So while it is sleeping for 2 seconds, your child thread will complete processing. You can see that it has completed processing. Once it has completed processing, which means it will come out of the run method. When it comes out of run method means it will enter into terminate status. And the thread is in terminate status, which means the thread has no use. Now you can see that the thread status is false. fte.isAlive is false now. So this sleep method is not a proper solution for identifying whether the child thread is completed or not. If at all, in our current case, when I execute the code, my child thread has completed, but still my main thread is in sleeping mode. That means even though CPU cycle was available, I am not able to put my main thread into running status. The reason for that is it is in sleeping status or blocked or waiting status now. So to avoid such type of stuff, you have one more option, which is join method. The join method is also an instance method, and that means it's also called on a thread object. So currently our thread is FTE. When we say join method, this particular line is executed by a thread. So we are asking that particular thread to join the end of the call stack of FTE. So that means when you say FTE.join, let us check the thread status before and after. So here I'm removing Here I am removing thread.sleep method. Your join method also throws interrupted exception. So you should handle the interrupted exception. When you say join, so currently this line, who will be going to execute this line? Your main thread. Once it has completed executing the start instruction, it will start, your main thread will start executing the next instructions. It will execute this instruction. It will execute this instruction. So when it executes the join instruction, the join indicates that, hey, this is my child thread, or this is the thread which needs to be completed first instead of executing the rest of the code. So join the end of the call stack of mine. So what is the call stack for this FTE? The call stack for this is run method.
Krish, can you just repeat, Krish, please?
Yeah, sure. The child thread call stack. What is the call stack for FTE? The call stack for FTE is run method. Whenever you say FTE.join method, so this method or this instruction will get executed by your main thread. So what you're telling is you are informing to the main method, join the end of the call stack of FTE. So this is the call stack of FTE. Currently FTE consists of only run method. Let us say from your run method, you are creating some other objects and you are going to call the display volume method. And the display volume method, let us say it calls print info method. So currently, this is the whole call stack for your child thread. So when you say join on any thread, whoever will be going to execute this line, they are supposed to wait until the call stack has completed for FTE. So currently the call stack is the child thread stack. So until the child thread has completed, call stack has completed means the child thread has to finish because it has only one method, which is run method. So until the run method has completed, this will be going to wait. Who will be going to wait? Whoever will be going to execute this statement. So currently this statement will be executed by your main thread. So your main thread will be going to join the end of the call stack of your child thread. You can see that your main thread details, child thread arrive status, it has executed upfront because your join statement was once after that. And once it has seen that the join statement was available, that means I'm supposed to wait until the FTE has finished its execution. FTE thread has finished its execution. I'm supposed to wait. Here I mean my main thread. So child thread has completed. Here you can see that child thread has completed. And once the child thread has completed, it knows that, yeah, FTE tells that, yes, I have finished my code. You can start executing the rest of the code. Then it will wake up and it will start executing the remaining lines. So at this point of time, if you verify the child thread status, it should display as false only because the join method informs that the child thread has to be completed first. When the child thread has completed the ISTQB status, it should be false only. So normally we'll use join method exactly. We are avoiding sleep method and we are placing join method. See, here you are not specifying how much time you are supposed to wait. You are simply specifying that wait until this thread has finished. So this thread, once this thread has finished, then only it will start executing the rest of the code by main thread. So if I remove this one, let us say if I have removed this one. If I have removed that, check about the sysout statements. The first one is main thread details. The next one is child thread alive status, which is true. The next statement also child thread alive status and main thread got completed. Main thread completed is the last statement of my main method, which means the main thread has terminated and then only the child thread has started processing, which is not a valid case. We are supposed to wait until the child thread has finished. When I place the join method, so we are asking the current thread to wait until this thread has finished the execution. So here you can see that child thread alive status is true, and here you are mentioning that join my call stack. So that means the child thread has started and child thread has completed. Sorry, and now you can see that the child thread status is false, which means the child thread has completed. Can we create methods in child class other than run? Yeah, you can write any methods, whatever that you want, no issues. But your thread execution will start only from run method. If you write some other method, let us say this is a class, you don't have any restrictions. Print data. No issues. You can call those methods also from your run method. Even you can create an object from your run method, just like how you are creating objects from your main thread. You can still create number of objects from there, and you can span any number of objects, and you can call the instance variables or methods by using those objects. We'll take a look at them in a minute. Now, we have mentioned that by using main thread, we can create any number of child threads. So currently I have created the first thread, which is FTE. Now I'm going to create one more thread. First, second thread, ultimately I'm supposed to call the start method, but before that I want to distinguish my thread. Set name. This time I'll specify that as second thread. I'll change this to first thread. And I'm calling the start method. Here you are mentioning only that join the call stack of FTE. But once it woke up, let us say FTE has completed. But once it woke up, we are supposed to wait until second thread also completed. So you should call second thread also. By using second thread object also, you need to mention that go and join. Once you woke up, go and join my call stack. So now verify. So here we need to identify which thread will be going to execute or which thread will be going to print the information. So I'm just modifying our thread code, and I will add the name of the thread here. So I'm printing the name of the thread which will be going to execute the statement. So it's not required for you to create a separate object for thread and then call the method. You can use nested method calling. That means once after thread.current thread, you can apply the dot. So once after that, you can still call the next method. What it will do is it will execute in this way thread.current thread, and it will inherently create a thread object. So this will evaluate first and then applies the dot operator. So that means this thread object, it will get created inherently and it will apply the getName method on that particular object. You can go any level by placing the dot operation until you get a primitive data type, or else until the method doesn't return void. Let us go and execute the code now.
Chris,
Yeah.
the last program, the threading. Yeah, here this is going to store in stack only, right?
Thread.current thread will return a thread reference. That means it will point to an object, right?
Yeah, object. That's okay.
So object means
showing, yeah, go ahead.
okay. Now go and verify the code. You have started the first thread. You have started the second thread. So both the threads have started now. The first thread alive status, it has printed directly. Once after that, you are specifying that join my call stack. And for second thread also, you are specifying that join my call stack. So your main thread, first it will join this call stack. Once it has completed, it will wait until this one also gets completed. Once it woke up, it will go and execute this particular statement, which is false value only, because we already know that child thread will be going to complete first. And here you can see that when you have started the first thread, it will enter at this level. You can see that it is printing the name of the thread because we have specified the name of the thread to be printing here. And it has executed all the instructions by using the first thread only. By using first thread, it has executed all the statements. Let us execute one more time. This time, previously, your first thread has got all the CPU cycles and it was completed all the statements until the termination of the run method. But in this case, when I have executed multiple times, you can see that the first thread has executed 3 times and the CPU cycle was given to the second thread and it has executed until the completion, and again the CPU cycle was given to the first thread. Finally, your main thread. So at this point of time, 3 threads. One is the first thread, the second thread, and your main thread. These 3 are available in runnable state, and one has entered into running status, which is first thread. When it has entered into running state, the CPU cycle was given to that and it was able to enter, and the thread scheduler feels that this is executing more number of times, and it has simply moved that back to runnable state, and it has given the running status to some other thread. So which thread will enter into running state? It was solely dependent on the thread scheduler. We can't control at any point of time which thread has to enter into running status. Your thread scheduler can give the CPU cycle for all the thread until the completion, or else it can ask the thread go back to the runnable and wait for the next CPU cycle or next selection. So that's what happened with this particular execution. If I execute one more time, this time it has executed 2 times, and the second thread got the CPU cycle now. This time you can see that the first thread has executed until the completion, and your second thread hasn't started yet until the first thread has completed. Thread entering into running status from runnable, it is only decided by thread scheduler by using some algorithms, and we are not supposed to write any code based on thread scheduling algorithms. Which thread will get picked up and enter into running status? It will only taken care by the thread scheduler. Can you try to remove both joins and see the result? If I remove the join statement, my main thread will complete first. You can see that the main thread has completed, and my child thread, the first child thread, it is still running, and my second child thread, it is also still in running status. So you shouldn't leave the join statements.
Chris?
Yeah.
Did they go to the sleep, the first one, when the second one started? When the second one became running, the other one was supposed to wait?
The second one, see, the first one, it has entered into running state.
Yeah.
The thread scheduler, even for executing the program also, it was supposed to get a CPU cycle, right? Yeah. When it got the CPU cycle, first time, it has given that to thread 1, which is in the running status. And when it got the CPU cycle for the next time, or else the thread schedule can decide within the same CPU cycle that this thread is running all the time, and it can switch back to runnable directly, not to blocking or waiting. It is directly jumping into. Yeah, we'll discuss about that.
Okay.
It will simply, the thread scheduler will ask this thread, hey, go and sit in runnable. You are running for too much time, and I want to give the CPU cycle for some other thread. There is one other method, which is yield method, which will be used to transfer the method directly from running to runnable. You can also call the running thread to go to runnable state by using yield method. Yield method, normally the English meaning yield. You are giving away to some other people. In the same way, here also, relinquishly, this thread is giving the CPU cycle to some other threads, and you can't guarantee whether the thread scheduler can choose a different thread this time, or it can choose the same thread and enter into running status. You're just informing that, yeah, I'm a good guy, and I can give my CPU cycle to some other person, and I'm executing the code for a long time. But your thread scheduler won't be smart enough to understand that you have already executed or you have already used the CPU cycle, and it can choose the same thread for entering into running status, or it can choose some other threads as well.
Hi, Krish, this is Adil.
Adil?
Yeah, I'm just a little confused with the concept of join, because I was under the impression that the whole execution of that particular method of that FTE is going to complete first, and
Exactly.
then only it's going to go to the next one. So why is it that it stopped at 3 and then it gave 2 to second and then it went back and completed the first one?
FTE.join, you are only informing to the current thread. So who is the current thread here? The current thread is your main thread. But you have already started the second thread. If you have placed the second thread starting at this level, it won't execute that particular code and it will wait until the second thread has finished. Even if you enter any number of times, it will work in the same way. But currently what we have done is we have started both the threads.
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website h2kinfosys.com. On our website h2kinfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.